long before a web page appears, before a single word of it has even been asked for, your device says hello, not to you, to the machine on the other end. It is the very first thing that happens on almost every encrypted connection you make. A short burst of technical introductions sent out in the open, and it is far more revealing than it looks. In that opening message, your device lists, in a very particular order, every kind of encryption it knows how to speak, every version of the protocol it will accept, every optional feature it is able to switch on. It thinks it is simply being polite, working out how to keep the rest of the conversation private. But the exact shape of that greeting, the precise contents, and the precise order they arrive in is different from one piece of software to the next, and that difference can be squeezed down into a fingerprint of the connection itself. This is the story of how the simple act of saying hello can quietly give you away. A handshake. Start with what actually happens in the instant before an encrypted page loads. Your device and the server cannot just begin trading secrets. They first have to agree on how they are going to keep those secrets, which cipher they will use, which version of the protocol, which keys, so they run through a short negotiation called a handshake, and your side speaks first. That opening line is called the client hello, and it is essentially a menu, a full declaration of everything your software is capable of, offered up so the server can pick from it. And here is the important part. This greeting is sent before the encryption is switched on, which means it travels in the clear. The server reads it plainly. And so, in principle, can anything sitting in the middle of the connection. The conversation that follows may be locked tight, but the introduction that sets it up is spoken out loud. The menu, and that introduction is not one simple thing. It is a stack of lists nested inside one another. There is the set of protocol versions your software will accept. There is a list of cipher suites, the named bundles of encryption methods, offered in a deliberate order of preference, from most wanted to least. There is a collection of extensions, optional features that have been bolted onto the protocol over the years, each carrying its own identifying number. And tucked inside some of those extensions are yet more lists, the mathematical curves your device will use to exchange keys, the signature methods it trusts, the higher level protocols it is willing to speak once the tunnel is open. Every one of these is laid out in a specific sequence. It is less like a single word of greeting and more like a long, ordered form, filled out the same way every time by the same software. Why it varies? Now here is the part that makes it useful for identifications. You would assume every modern browser sends more or less the same greeting, and they do not even close. Each program that speaks this protocol was written by different people who made different decisions. One browser's engineers chose to offer these ciphers in this order and to include these particular extensions. A different browser, or even an older version of the very same one, orders them differently, leaves one out, adds another, or arranges the extensions in its own sequence. And the deeper library matters just as much, because a program that borrows its encryption from the operating system inherits that system's habits, while a program that ships its own library carries that library's signature instead. The ordering is rarely arbitrary. It reflects the choices, the priorities, and the accumulated history baked into that one specific software stack, which is exactly why it differs so reliably between them. So take that entire greeting, the protocol version, the ordered list of cipher suites, the ordered list of extensions, the curves, the signature methods, all of it, and write it down as one long string in a fixed, agreed format. Then run that string through a hashing step, a process that crushes any input down to a short, compact label. The same software in the same configuration will produce the exact same label every single time. Change the software, and the label changes with it. That short label is the connection fingerprint. Notice what it describes. It does not describe you, the person, and it does not describe the content you are about to request. It describes the machinery making the call, the particular program on the particular system that just introduced itself, distilled into a handful of characters that can be looked up, compared, and remembered before the page. And it is worth dwelling on when all of this happens. because the timing is the whole point. The handshake is the first thing on the wire. It comes before the request for the actual page, before any cookie is handed over, before a single image or script is loaded, before any code from the website has had the chance to run inside your browser at all. Which means the server can compute this fingerprint right at the doorway, in the opening few milliseconds of contact, and decide how to treat the visitor before it has shown them anything whatsoever. This is identification that runs ahead of the content entirely. A judgment formed during the introduction before the real conversation has even begun. The tell, and this is where it becomes genuinely powerful for the people defending a service. Every ordinary web request also carries a plain, human-readable label that the client writes about itself. The user agent, a line of text that says, in effect, I am this browser, this version, running on this operating system. The trouble with that line is that it is trivial to change. A program can claim to be anything it likes, and automated clients routinely do. But the handshake underneath is a far harder thing to fake, because it comes from deep inside the software, from the encryption library itself, not from a label anyone can casually rewrite. So a server can simply hold the two up side by side and ask, does the greeting match the claim? If a visitor's user agent announces a mainstream browser, but the handshake looks nothing like that browser's known greeting, if it looks instead like a bare scripting library or an off-the-shelf automation framework, that mismatch is a loud and early signal. The client is wearing a costume that does not fit its own body, and the server noticed before the page had even loaded. Nothing to delete, and here is the property that tends to unsettle people once they see it. This fingerprint is not something stored anywhere on your device. There is no file, no cookie, no cache entry, nothing saved that you could hunt down and remove. It is generated fresh out of the software itself. Every single time a connection opens, you cannot clear it because there is nothing being kept to clear. You cannot slip past it in a private window because a private window runs the same browser using the same encryption library and therefore sends the very same greeting. The fingerprint is a property of the program that is running, not of any data that program has stored. Short of switching to genuinely different software, or reaching in and altering the software's own behavior at a deep level, the greeting simply stays the same, connection after connection, day after day. It is worth being honest about who actually uses this and why, because it is not only the trackers people picture. Yes, an operation that wants to quietly recognize returning devices can lean on it, but the loudest and most common users are firmly on the defensive side. Fraud teams use it to notice when a flood of login attempts all share the fingerprint of a single automation tool, even as those attempts parade thousands of different user agents to look like a crowd. Bot detection services use it as a fast, cheap first filter right at the edge of the network, a way to sort obvious machines from likely humans before spending any real effort on deeper checks. Content delivery networks lean on it to triage traffic during a flood. It is valued precisely because it arrives early, because it is hard to forge in a casual way, and because it costs almost nothing to compute and check. The defense is, so how does the other side respond? The side that would rather an unusual greeting not be held against it. Part of the answer is convergence. As the major browsers have matured, their handshakes have drifted toward a smaller set of common shapes, so that more and more ordinary users end up sharing the same greeting and blending into a large, unremarkable crowd, which is the safest possible place to stand. Some privacy-focused clients deliberately smooth their handshake toward that common shape for exactly that reason, to look like everyone else rather than like themselves. And on the detector side, the responsible practice is restraint. A fingerprint mismatch is treated not as a verdict, but as one weak signal among many, a reason to look a little closer rather than to slam the door, precisely because so many perfectly honest clients are simply unusual. A system that blocks every unfamiliar greeting will spend its life turning away real people. The careful ones weigh the handshake against everything else the visitor does, and let a strange hello raise a quiet question rather than pronounce a sentence. The arms race. And of course, once the people running automation understand the tell, they set about closing it. The obvious move is to make the automated client's handshake imitate a real browser's greeting as closely as possible. The same cipher order, the same extensions, the same curves, the same everything, so that the fingerprint lines up with the user agent it is claiming to be. And up to a point, that works. So the defenders refine in turn. They look deeper, at subtler corners of the greeting, at parts that are genuinely difficult to reproduce faithfully from outside a real browser, at whether the rest of the connection then behaves the way that browser truly would, at how the greeting is supposed to shift from one version to the next. And there is a lovely trap built into imitation. The copyist freezes a known good greeting and reuses it, but the browser it copied keeps updating, and before long the frozen greeting has gone stale, now matching a version that no longer exists anywhere in the wild, which is itself a fresh kind of tell. It is a slow, continuous contest, each side studying the other's moves, and neither one ever quite finished. The double edge, and it would be dishonest to tell this as a clean story of catching villains, because the very same signal that flags a fraud ring also flags people who have done nothing wrong at all. A privacy-minded person running an unusual but perfectly legitimate browser can send a greeting the server has simply never cataloged and be treated with suspicion for it. A company that routes all of its staff through a corporate security appliance can have every employee's connection rewritten into one odd uniform handshake that matches no ordinary browser, and find its whole workforce flagged in bulk. An older device, a niche operating system, an accessibility tool, a rare but honest configuration, any of these can produce a greeting that sits outside the expected set and be quietly penalized for the crime of being different. The technique cannot tell malice from mere unfamiliarity. It only knows whether your hello looks like the crowd's, and the same sharpness that catches the automated attacker in the doorway also catches the merely unusual traveler standing right behind them, what it is really about. So here is the thought to sit with. You tend to imagine your privacy and your anonymity as living in the things you can see and control, the cookies you can clear, the history you can wipe, the name you were careful never to type. But some of the most telling things about you online are spoken before you have done anything at all, in the very first breath your device takes as it reaches out to a server. The way your software says hello, the exact order in which it lists what it can do, is a signature you did not choose and cannot easily change, written by the people who built the program and carried faithfully into every single connection it opens. Long before a page loads, before you click or scroll or read a single word, your machine has already introduced itself, and for a great many watchers, that introduction alone is enough to know it again the next time it comes knocking. If this is the kind of thing you find yourself thinking about, the quiet machinery under the everyday internet, then this channel is your sort of place. There is no product to sell you here. It is just the systems taken apart and explained by someone who has spent a long time on the inside of them. Subscribe and follow the rabbit hole. Next time we are going to leave the machinery behind and look at you. Not your device, you. The physical way you type, the tiny rhythms in how you press and release each key, the wandering path your mouse takes as it drifts toward a button, the exact pressure and arc of a swipe across a screen. All of it can be measured, and all of it turns out to be astonishingly consistent. An identity written not in your hardware but in your habits, a signature you cannot delete because you never even knew you were writing it.